Kia ora. What happens when you have more than one functional group present in an organic molecule? Well, the answer is you need to have a priority list, and this is the order you need to know for NCEA Level 3. The carboxylic acid is the most important and takes priority over the aldehyde, the ketone, the alcohol, the amine, the alkene, and then the halogen and an alkyl side chain are the same priority. So when we have two or more functional groups, then the one highest up in the list will always get the ending, and then the others change from the normal ending and become a substituent. So an aldehyde changes from L to oxo, ketone changes from one to oxo, ol to hydroxy, amine to amino, and the alkene, alkyl side chain, and halogen stays the same. So one way you can remember this priority list is if you think of a keen hurricane supporter who is inviting people around to his place for a party or something to celebrate, but he's got a great big hole in the carpet, so he puts a box over it. So you can think of box hides one hole means keen hurricane. Very silly, but perhaps it'll help you remember. So carboxylic acid, aldehyde, ketone for one, ol for whole, amine means alkene, kene, and hurricane, so halogen, and the alkyl that comes from an alkane. So hopefully you'll remember. So here's a molecule that has a carboxylic acid and it has an alcohol. So the alcohol now becomes hydroxy because it's lower in priority, and we have to number from the right because the one highest in priority always gets the lowest possible number in the parent chain. So this would be 3-hydroxybutanoic acid. Here's another one very similar, and so it's carboxylic acid with an amine group, and so the amine becomes amino, so it's 3-aminobutanoic acid. What happens if I have an amine with an alcohol? Again, you look at the priority, so alcohol trumps your amine, so the alcohol gets the lowest possible number, so we count from the right, so it'll be 4-aminopentan 2-ol to give the ol the lowest possible number. Here's an alkene with a chloro. So this is something you've come across before. So the alkene trumps the halogen and therefore gets the lowest possible number. So it would be 4-chloro, 2-methyl, pent 1-ene. The side chain, alkyl side chain, and the chloro are on the same priority list. So there's no difference there. We just put them in alphabetical order. That's why chloro is ahead of methyl because of the alphabetical order. Here's one with an alkene and a alcohol. So the alcohol trumps the alkene, so that gets the lowest possible number. And so we have to start numbering from the right. And so it'll be 4-methylpent 4-ene 2-ol and not the 1-ene that we had. And the ol comes at the end. So here finally is just in case you were interested, it's highly unlikely you'll get this in the exam, but what happens if you have a ketone or an aldehyde? How do you know what they are if they're both oxo? So here's an example. They've got a carboxylic acid and there's an aldehyde and there's the ketone. And the aldehyde and ketone gets trumped by the carboxylic acid. So we end in oic acid, and this will be 3-oxopropanoic acid, and this will be 3-oxobutanoic acid. And the way we know whether one is aldehyde and one's a ketone, propanoic, 3 carbons in a row. So 3-oxo means I'm on the third and last carbon, so it must be an aldehyde. Here it is 4 carbons in a row, so 3-oxo means I'm on the second to last carbon, so therefore it can't be an aldehyde, it must be a ketone. So I hope you now will remember your priority list and be able to name compounds with more than one functional group. Kia ora.